So I suppose the next job I ought to do is focus on the DRO if nothing else gets in the way, and switch the old biter on. Is it working? It would appear so. Now then, I think the table is locked at the moment. That's okay. Now, before I undo it, I think I'll take up the slack on the lead screw, which is duly done, I think, and it's ready to advance. So, as I undo the X table now, there might be a slight deflection that could be measured on the DRO. I'll have to see. Yep, I thought that might happen. Okay. Well, if we convert that to millimetres, it's not going to register, so I don't think I'm going to have to worry about that. So we're zeroed out, just to make sure. What the hell was that? I think that crack was maybe the button making a noise, a physical noise rather than an electric noise. That ever so slightly worrying at first, but yes. So really, we have to go out to what diameter? Shall we risk it and go to 123? Well, as we're doing some test marks, I think we will. So we want a 123 millimeters. Now, I suppose we ought to really move the table back. Not the camera, sorry. Back to where we really want it. Right, now we will have to advance the table. I wonder if I should really get rid of this bolt out of the way. I think the milling cutter is actually just high enough to miss it. I think it will. I think so anyway. We'll just have to see. Now hopefully, because the table is now loose, it will move when asked to. It's going now. Now unfortunately, the digital readout, rather than going down to 0, is actually advancing. So really what I need to do now is not go to 123, I need to go to twice that, which is 246. How daft am I? I should have put a minus figure in. So the milling cutter is well above, so that's okay. What did I say? 246. So you can't see the DRO, but I can. So we're coming up to 225, 230. Go to 246. There's a bit of a wear in this lead screw, so that's why I'm a little bit cautious as to doing the first cut. We're nearly there. I'm just getting a bit pedantic now and dialing it in. It's a bit like filling up fuel at the petrol station. You don't want to go past 0. So bang on 246 millimeters. So next time I'll do a minus figure. So I always forget which is positive X and negative X. So I'm just gently tightening up the X table now. Hopefully we'll get a deflection. I don't think it's really going to matter if it gets into like a 20th of a millimeter deflection. Just quite a amount. So, okie dokie. So theoretically, if this milling cutter came down now, it would end up describing a channel, and the edge will be right on the money. You can see how close the end mill, I don't know whether you can actually, how close the end mill comes to our 14mm hole. Now that's simply because of the size of the mill that I'm using, but if that is the edge that should be theoretically about 3mm away, because the channel being 230mm wide and the holes for the motor being at a diameter of 215mm wide, that means that we have a very small amount of space left for the bolt head on the other side. Yeah, that's quite true actually. But anyways, I think I've talked about that in a different video. Must have been when I still thought it was 235 and had an extra 10mm to go on either side. That is going to cause a bigger problem. Oh well, we shall. Oh no, that's quite correct. Oh, for fuck's sake. Now, as it just happens, the rotary table has been turned around in the last operation, and the holes have ended up here. I've not advanced the plate to this position as it's been mounted now. It just turns out that that's where they arrive. But it has allowed me to look at where the edge of this mill comes. Now, this should now be exactly where we want the end of our edge to be, which should be at 230mm. Now, in a previous video I must have made the error and took it on board that motor mounting was actually a diameter of 235, and that wouldn't have posed too much of a problem, because the radius, or shall I say the diameter for now, at which these motor mounting holes here for the new motor is 215. Now, had the edge at which I want to create this channel been at 235, I'd have had an extra 10mm from the centre points of each one of these holes, which meant that the head would have had to have been no bigger than 20mm, and you can go out and buy 14mm Allen bolts or cap head bolts, which have heads no bigger in diameter than 20mm, so they've been perfect. But of course, when I double checked to make sure that I didn't mill in the wrong place, and found out that the true motor mounting was 230mm, that means I have 5 less millimeters to play with, and that does create a few problems, because instead of having an extra 10mm of radius on each side, I find I've only got 7.5mm extra radius, which would theoretically mean that my bolt heads would be, or could be, no bigger than 15mm, which for a 14mm bolt is pretty bad. So I now have really no other choice but to grind a little bit away from the inside of the motor mounting to make way for the heads. That would be a minimal amount if I was to use Allen bolts, because the heads are obviously round, but if I choose to use these hex bolts, which I've already got, I'd have to mill away even more. It's not the best scenario, unfortunately. This is something which I can grab hold of with a much bigger spanner than using an Allen key in what would be a cap head bolt. So really we're looking at milling away quite a large amount of steel from the inside of that motor mounting, but I certainly don't think it's going to make it any weaker than it already is. It's just an extra job which is going to be a pain to do. but of course me seeing the tip now just made me jog over those figures. So theoretically, if I've only got an extra 7.5mm radius from the centre point of these holes, I know there's a lot of mass, but I'm hoping you can keep up with me. If you can, it's a good thing, because I'm having trouble keeping up with myself. The centre holes for these were at 215. The channel has to have its edge at 230, so we only have 7.5 extra millimeters to go at in radius, and we've already taken up 7mm of that by the actual hole itself being 40mm diameter, 7mm radius. So we've not much to go at. Now this tip here of the mill is looking to be decidedly further away than 0.5mm from this hole, so I'm hoping the holes are okay, because the DRO doesn't seem to want to lie. But I'm going to do a short cut here and a short cut on the other side and see if they are the right distance apart from each other. So we'll have to give that a shot. Well, I must have been right to put B on for blunt, because I had quite a bit of trouble, as smooth as this looks, I had quite a bit of trouble actually getting it to cut through, even at a modest depth of about 1mm. So I think what I'm going to have to do is abandon that flute cutter and actually use a slot drill, which I suppose maybe I ought to be using anyway, because at least one of those flutes goes over the centre and clears away the bottom. But I think the problem with this one is that the edges are blunt, so obviously as sharp as even they felt, it's not good enough, so I'll have to put this one in instead. Oh well, not to worry.
Well, you can tell this has only got 2 flutes on it, because it's a lot less smoother cutting. No, I was going to react over the holes. It's a lot less smoother cutting than the other mill, which is just a general end mill. Now, the only thing I'm worried about is it is now past 11:30 at night, and this is quite noisy. So I'm just going to have to see how far I can get with this before my conscience gets the better of me. Certainly enjoyable. This may actually be cutting a line at 180mm. Not 180, I can't remember what it was now, 230. It's interesting, the chips all going around in a circle. It shows you there's a lot of vibration. Not too keen on that. And now we're jammed for some reason. Oh. I think what's happened is that the lock for the worm drive is not broken but loosened itself. I'll have to tighten that back up, or re-engage it at least. Yeah, that's exactly what's happened. Yeah, so we can tighten that back up again. Catching the camera at the same time. Hopefully it's about the same depth. And try again. Same old noise. I don't think I'm going to get away with this for very long. Actually, people in Britain don't complain, so... I think if it's worked itself loose once, it might do it again. Coming up to the edge now. That's a slight relief. But I think this, you can't see it's out of shot, but what's happening, I'll just lift this up for a second. I almost didn't do another cut. What's happening is that I am winding this around and it's becoming loose. You can engage it into the worm drive and all the vibration is making this come loose. So as I'm winding it round, it's slowly but surely disengaging from the worm gear inside the rotary table, and it's only a matter of time before it stops again probably. I'm too nervous, I really am. I may have to stop.
Well, I've just finished milling away the final edge to this, and now we have this at bang on 230mm in diameter. The depth is probably only about 3mm. Let's have a look. Yeah, maybe slightly below 3mm. So, well, there is some argument as I should make this deeper, on, you know, mill away a bit more of this surface and create a deeper spigot for locating. But I think what we've got will be okay. I don't want to do much more, or any more to be honest, because I had a few issues with the backlash in the rotary table, and as we were using only a 2-flute end mill, it was not quite as gentle as I thought it may be. It was almost akin to using a pneumatic drill, because obviously once one of these points leaves the cutting surface, the radius is not as great on the rest of the cutter, and so you get a lot of vibration, and I don't think the vibration did the rotary table much good. I think there's something a little bit loose in here, because towards the end of the milling operation I was finding that this would jam and I couldn't turn the winding handle with the worm gears involved. So that's a little bit worrying. So I don't really think I should do any more with the plate now, but there's a slight early indication that these holes are where they should be in relation to the center point, because the gap that I seem to have got left between the end of these holes and the spigot edge diameter is basically the same for each one. I'm not going to be able to really zoom in with the camera too much, so it'll go out of focus in next to no time. See, it won't handle that very well. Come out a little bit more. You can see that the edge is almost touching. I think really that should be about 0.5 millimeter away, which I think we had a diameter here of 230, and we had the holes that were all drilled on a centre of 215. So the difference between the centre line of these holes and that holes was, I've lost my figures now, 215 for this, 230 for this, so we're looking at 7.5 mil from the centre of this hole to the edge of that line where the spigot is, and because the holes are 14 millimeters wide, there should only be 0.5 millimeter there. And it seems to me as though there is about that amount of space left on at least this hole. If I disengage the table gearing and then wind the table around to the other side, I think we have about the same space there, and I think we have the same one on that side, and we have about the same on that one. So really what I have to do now is decide to, rather than doing any more milling, I could still recenter the table by the method that I used before. if it wasn't quite up to size, but I think it's going to be fine. I think I'll have to take a couple of bolts out of the motor mounting because there's two on the left that won't come out. I've decided to stay in there, whereas the other two, once you unscrew those, they all come out. So really I can probably test this plate now, perhaps, if those two bolts will allow this to centre. But of course these holes that I had trouble with before, perhaps they may be throwing the centre point of this plate off. So whether I can actually test this spigot, whether it fits or not, and have the two of the bolts going through these holes, might be a bit risky. But I think I'll give it a go. So I'll see if I can zoom out here. The other thing which I never noticed, really, you might think it's daft, until I finished, was just how many chips I produced. Look at all this. That's really quite deep. Might save some of that for when I do the aluminium melting, stuff it all at the bottom and create a good amount of surface area for other chunkier bits to get some heat to them. But I think I'll leave those there for the time being. I'm a bit too anxious to see whether this plate fits, so we'll just adjust this again. I suppose the next job I'll be doing is undoing the plate. So, oops, dropping my brush. Daft as one sometimes. Right, let's get rid of all these chips. We don't need those. We might do with some chips actually. I'm glad these lock nuts were on here. Oops, I suppose we want to lock the table. Yeah, I'm not quite sure what the problem with the gearing was, but this plate was adequately secured to the rotary table, absolutely no bother at all. But it seemed as though there was a problem with the gearing, going out of mesh or jamming. And I can't imagine what it was getting jammed with. This is certainly not aluminium chips. That hole would allow the chips to drop, minimal amount of chips to drop straight through the centre of the rotary table. It certainly wouldn't pose any problems for the gears jamming. So I think really all the vibrations maybe not done it too much good. What I'm going to have to do is take it apart and see what's what. I may even make a video on it if you're all particularly bothered. I think it'll be more if I'm bothered than anybody else. So, take the washers off. Put them out of the way somewhere. I pocket. Right. So, what I'll do is I'll just stick that there for the time being. Move the camera. Some light on. I'm just going to go under the lathe. Switch that light on. Move the camera first, I suppose. Come on. Right. Turn it down here. There we have the motor mounting, where the plate will hopefully fit. I thought I'd do this in one shot to see if I was any good at getting this to go right. It certainly needs deep burring, this plate on the outside edge. So what we've got is a freshly machined, although the surface doesn't look brilliant, but I don't mind. This is the part which will hopefully fit into here. we've got a few issues with these bolts either fitting or not fitting through here, but if we can get this to go absolutely flat, I think that was the best position, then we can worry about these bolt holes there. So what I'm expecting now is that I can get this one out, I can undo that one. Oops. I think I'll give myself the best chance actually. These two would just need a couple of pair of pliers to just undo those. Sometimes these bolts stay in the motor mounting, sometimes they come out, depending on how tight they were in previous operation. So I think we'll give it a go. So those two holes are, not sure that was the best set to choose. No, I don't know whether they were the best set to choose. Let's rotate it around a bit. That seems to be a better chance. Come on. Is it flat on? Let's have a look. Hey chaps, it's flat at the bottom, that's for sure, but not quite at the... Oh, it is! It is! It's in! It's bloody in! God, it's no play whatsoever! Oh! That's superb! Oh, there's no play at all. I wish I could take these out. See if I can. God! Is that flat at that edge? I can't really tell. Oh, there's no play. And if it must fit. Because if I was to take this plate out... Oh, come on. Oh, well, there's no play doing that either, that one, it's not certain. But there was no gap between this plate and the motor mounting. So, see if we can get these out. Oh, hopefully that's a good result. Pliers. No idea whether these will work actually. See if we can get these little jesters out without ruining the threads. Probably not the best tool to use. I suppose what we should do is put a nut on there and another nut on there, make it a lock nut. I'm trying to do it that way, perhaps. Is that a good way of doing things? Come on, give it a go. Put that one on there, like that. What size socket does it need? That is a clever question. I do not know. As it happens, is it that one? It is that one. Alright, fair enough. Let's see. No, that's undo it. Let's get that tight on there. Oops. Tighten that. I'm doing the whole thing. What I of course do is just do these. Stupid boy. Anyways, worth a try. I'll do those, you know. Let me cut some of this footage out, it can't be that interesting for me. That's undone. That's good. Just tack on that. Oh, she's undone. Aye, father's in. So, undo that one now. I'm glad they didn't pose too much of a problem coming out. Right, this is the true test. Doesn't matter where I put this now. If this fits in here, we're laughing. It does. And there's no play. Woohoo! God, there's nothing there. No play at all. Oh. I might be able to rock it maybe less than half a millimetre, something daft like that, but maybe I'm just thinking I am. Good God, I can't detect any movement whatsoever. Oh yeah! Oh yeah! Oh, it's worked, boys. Oh God, I'm gonna have to do that again. Oh, it's perfect. Right. My next thing is to drill an hole in there and see if the motor fits these holes. Get a good indication that they were quite where they should be, because these gaps here between the edge of the bolt hole and the spigot line were the same on all of them. So that will be the next test, to put a hole in here. Oh dear. That's a nice bit of luck. That is a nice bit of luck. Oh yeah, that's a good plate. I can't move it a bit. Perfect. Absolutely bloody perfect. These holes aren't. But now it doesn't matter anymore, because the plate is located. So we can make these, we can just ream them out until the bolts fit through. Doesn't matter if some holes have to be reamed out bigger than the other ones. It doesn't matter because it's already located. That's the idea of these spigots, is to make sure that the motor and the pulley are as concentric as possible. And I'm quite confident now that they are. What's the next job that I should really seriously think about doing? There's the hole I need to do, and see if the motor fits on here with the bolts through. There's something in the back of my mind that I'm sure I ought to do. I don't know. God, it's absolutely perfect. It's about time I had a bit of good luck. Right, crack on.